Hello again, and thanks for joining us on another episode of Space Nuts, where we talk astronomy and space science. My name's Andrew Dunkley. Thanks for your company. If you're joining us for the very first time, welcome to our little astronomical community. Coming up on today's program, we're going to look at one spun out asteroid and a superpuff planet as well. But the story that excites me most is what they've discovered about Martian groundwater and what it means for the history of Mars. That's all coming up on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And it is time to say hello to Fred Watson, astronomer at large, joining us as always. Hi, Fred.
Hello, Andrew. Very good to see you and hear you.
Good to see and hear you too. Yes. All is well, I take it?
Yeah, I was just going to mention, we heard a couple of days ago that Winton in Queensland has become Queensland's first international dark sky community. It's Dark Sky International is the global body that dishes out these things. But this little outback town, 1,000 people, they've put together the application and got themselves awarded the first international dark sky community in Queensland. So it's in fact, they join the Jump Up Dark Sky Sanctuary at the Australian Age of Dinosaurs to become Australia's 8th dark sky place. And I'm reading from my wife Marnie's LinkedIn post about that because I think she probably had something to do with it.
Probably,
Yeah.
Of course, it's a bit easier for Winton to be a dark sky community because they only have to turn one light off.
And that's right. It's almost like that. Yeah. Dark sky communities are interesting. We have here in Sydney the Southern Hemisphere's first urban dark sky park, which is actually a suburb of Sydney. It's one of the most remote suburbs of Sydney, and you can imagine anything anywhere near Sydney is not particularly dark. But this place is reasonably dark, and the main thing that qualifies them to have this status is that there is a willingness to preserve the night sky. So the lighting and, the policies that are in place, it's in Sydney's Northern Beaches, not very far from where we are now. And all those policies contribute towards the qualification for an urban dark sky park.
That's pretty cool. Yeah. I know Dubbo Regional Council, where I live, has done as much as it can do. Well, probably could do more, but, they've taken into account that the telescope up the road at Coonabarabran is not far away and that we are a factor in the light pollution problem. So we have different lighting in this city to curtail the effect. So all the lights point downwards. They're not bright white lights. They're more of an amber glow.
Yeah,
so,
that's great.
Yeah,
in fact, they're actually mandated to do that by the dark sky regulations that applies because you're within 100 kilometres, at least part of Dubbo is. Yeah, but Dubbo Regional Council, I think, is anyway, is it the Western Plains Regional Council? Is that right? That's
Midwestern Regional Council is the other one.
Yes, yeah. So that they are included within the 100 kilometre radius region, but actually for state significant infrastructure it goes out to 200 kilometres. So there's a few places further afield that would have to have dark skies. Yep.
Interesting, anyway, because a lot of people wouldn't really understand or even know about the requirements of dark sky policy, would they?
No, they wouldn't. They'd wonder why their lights are different colour from everybody else.
Yeah. So people in Dubbo who listen to this, and I know there are a few, will probably have a good look at the street lights next time they're out at night because they are different. They are different. Yeah. Let's get down to business. We've got quite a bit to talk about, and this first story is about one spun out asteroid. We've been talking about a lot of rocks in recent episodes, asteroids, comets, etc. But this one caught the attention of astronomers last year, and they've just published a paper about it.
Yeah, it's in fact, it's sort of hard on the heels of one of the stories we covered last week, or the episode before last, which was about the possible transfer of material between asteroid Didymos and its moon Dimorphos, the ones that were visited by the DART spacecraft. And it was thought that the spin of that asteroid Didymos had released material that might have found its way onto Dimorphos. But this is a different story, and it's research that has come not from a spacecraft, but from a telescope that you and I are going to talk a lot about in the next few years at the Vera C. Rubin Observatory in Chile, the 8.4 meter wide-angle telescope that is going to find all these really interesting time-related objects in the universe and time-related phenomena, what we call transient events. And I think it was last year, yes, you're right, it was last year, that the Vera C. Rubin Observatory caught an asteroid, which rejoices in the name as 2025 MN45. That's a typical asteroid name as bestowed by the International Astronomical Union, while it's still a provisional designation. It's about 710 meters wide, but is a complete basket case in terms of the speed with which it rotates. Because whilst an object that size would normally be rotating at a rate measured, in hours, maybe once every 2 or 3 hours or something like that, this one is rotating in 1 minute 54 seconds.
Yeah, wow.
And it's unbelievable. So the main question is, how does it hold together? Because, that rotation produces an acceleration at the surface that you would think, certainly if it was a rubble pile, it would have fallen to bits a long time ago. So that tells us it's not. It doesn't really tell us much more, though, except perhaps it may be a metal asteroid. We've got a metal asteroid on our horizons at the moment with a Psyche spacecraft on its way to the asteroid Psyche, which is probably not solid metal, but has a very high proportion of metal in its makeup. Maybe this is something like that. 2025 MN45 might be, the second predominantly metal asteroid to be discovered. We don't know, but it certainly is a matter of interest. It may be that it's got an odd internal structure as well. There might be, for example, just think of this one, Andrew. What if it's hollow? Or something like that, something really weird. Who knows?
Yeah, that would be strange. Although I would expect that at that kind of spin rate, being hollow
wouldn't help.
Wouldn't help at all. Its integrity might be compromised.
Yeah.
I just did a little bit of a thought experiment, and I looked up what would happen to Earth if it spun at the same rate as that asteroid. Now it's spinning 758 times faster than Earth. If Earth was spinning at that kind of speed, 1.9 minutes per rotation, it would be a disaster. It would destroy the crust. There'd be total liquidization. We'd lose our atmosphere. The wind speeds would be insane. And around the equator, there would be reverse rain due to the centrifugal force. So I am going upwards. But that's 758 times faster. But even if we were spinning 50 to 100 times faster, it would still cause catastrophic flooding, and the oceans would migrate towards the equator, and most of the land would be covered. It'd be a mess.
It would be a mess. We think the fastest the Earth has rotated in its infancy is about once in 4 hours. That's thought to be how fast it was rotating when it formed. But it's, of course, slowed down with the transfer of energy to the moon and things of that sort.
Yeah.
I think once in 4 hours was is what's thought to be the fastest, just pulling that from memory.
So that'd be 6 times faster than it is at the moment.
Yeah, that's right.
And even at that rate, it would be uninhabitable. I just did a quick check.
Okay. Yes, I'm sure it will.
suffering catastrophic geological and atmospheric changes. So,
I mean, that's right. I mean, I think it was still pretty molten at that time. So it was
going through its cooling phase.
Not a nice place to be.
No, it wouldn't have been. No. But if you'd like to read about this spun out asteroid as observed through the Vera C. Rubin Observatory in Chile, you can read all about it on the dailygalaxy.com website or the Astrophysical Journal Letters, where the paper has been published. This is Space Nuts with Andrew Dunkley and Professor Fred Watson. Let's take a little break from the show to tell you about our sponsor, Incogni. And if you've ever had your information harvested from the World Wide Web, this is the tool for you. Of course, your information is easily available online. We're talking personal information, we're talking addresses, phone numbers, email addresses, even bank details if your protection isn't good enough. This stuff gets harvested and it is sold by data brokers. They sell it to other people who then scam you or other people in your name, which is happening a lot. So what is the solution? Well, the solution is you can go online and clear out your personal data by yourself if you've got a couple of years up your sleeve, because that's how long it will take you. Or you can use a ready-made solution, and that is Incogni. And as a Space Nuts listener, you get a special deal with Incogni at the moment. It is simple, it works in the background, it provides ongoing protection, so you can sit back, relax, and know that Incogni is protecting you from these harvesters and scammers. And all you have to do is create an account, give Incogni permission to work on your behalf, and that's it. Job done. And if you want to check out the pricing, there's a 60% off deal for Space Nuts listeners at the moment. That is fantastic. Just go to incogni.com/spacenuts for more information. That's incogni.com/spacenuts and see what works for you. But peace of mind is probably, something that we all need in this world of data thieves. So check it out today, incogni.com/spacenuts.
Houston, Tranquility Base here. The Eagle has landed.
Space Nuts.
Now, we've heard about superpuff planets before, Fred. There's another one in the news. I think this one's Kepler 51d. Gee, they're finding a lot of planets out there, aren't they? And some really weird ones. And this is in the weird category.
It is, yes. It's a strange object, as you said. It's one of the exoplanets discovered by the Kepler space mission, which was very, very productive, observing planets going around other stars by the dip in the star's light as the planet passed in front of it. So Kepler 51d has been studied with the James Webb Space Telescope in order to try and identify the elements in its atmosphere or the chemicals in its atmosphere, which you can do when a planet with an atmosphere passes in front of its parent star, which is what's happening with Kepler 51d. Some of the light from the star filters through the atmosphere, and the atmosphere puts its kind of spectroscopic fingerprint on the light, so that when we use a spectrograph with a sort of prism or a similar mechanism for dispersing the light, then you can see the chemical signature of what's in the atmosphere, because its faint imprint is there. So they did that, and what did they find? Nothing. Not that there's no atmosphere, because they know this object, as you've said, it's a superpuff, which means it's an object. It's roughly the size of Saturn, so that's 9 times the Earth's diameter, thereabouts, something like that. But its mass is not that much bigger than Earth. It's a few times the Earth, so it's got a very low density. That's the bottom line. You've got something with a big diameter and a small mass, hence low density. As the one of the articles that reports this comments, planetary scientists sometimes compare such planets to cotton candy, which I think we used to call it candy floss.
We call it fairy floss.
Fairy floss, that's right. Floss. Yeah, I remember that stuff.
It's good to know that fairies do floss. It's very important for their dental health.
Yeah.
Seeing they are two fairies, most of them.
Oh, I love it. I love it.
There you go.
Yes, there would have to be tooth fairies. That's right. Yeah.
I was feeling fairy floss is not good for dental health, but anyway.
You're right. My only recollection of that stuff is it ends up all over your face. And
that's
understood. Anyway,
tough, especially when you give it to young children.
Yes. Or old men. That's right, though. It's something that it has a structure that is very different from our own planet. So what did they do? They said, we're going to find out what's going on here. Observe the star as the planet passes in front of it. Look for the spectrum imprint on the light coming through the planet's atmosphere. And what did they see? Nothing. And the interpretation of that is that the atmosphere, very high in the atmosphere, you've got haze. So haze is basically particulate matter. It's suspended in the atmosphere, and it's so dense as to block the light coming through it. So you don't see the imprint of what the gases in the atmosphere are. So an aerosol of haze is basically it's basically what's blocking the light, and what's giving these scientists, by the way, from Penn State University, they've sort of observed enough of the light to deduce that there is a thick haze layer there, but there's no sign of. As I said, it's blocking all the evidence of what chemicals you have. So the big problem now is working out how that haze got there, and what actually supports it. Why is this planet so hazy? And that is, I think, where the situation lies now. That you've got this world which is fairly cool in the sense that it's hotter than our planet is. It's way within the beyond the Goldilocks zone. But it's all about the chemistry that would, at the temperatures that we believe the atmosphere of this planet is at, the chemistry that would produce that haze. And that, I think, is an ongoing piece of work.
Yeah, just reading through the information, it seems to be related to temperature. Yes, it may be the cause of this. I'm guessing it's technically cooler than our own gas giants. Would that be fair to say?
Our gas giants at their surface are well below those temperatures.
Okay.
Surface. So the top layer of Saturn is, if I remember rightly, about minus 95 or thereabouts.
Right.
Or is it minus 195? I think it's nearer to minus 195. Sorry, I'm pulling numbers from old reports there.
So this one's much hotter.
Yes, that's right. Yeah. But the other interesting thing about this system, the Kepler 51 star, has, I think it's got something like 4, it might even be 5 known planets, and 3 of them are these superpuffs, very low density objects. So there's something going on in that solar system that really doesn't match what goes on in ours.
Yeah, I wonder if it's got anything to do with the star itself.
Could be. Yep.
Activating this situation. Hard to know. Or maybe they're affecting each other. I don't know.
It is a sun-like star, but it's at a much more youthful stage in its history than our sun is.
Well, that's why it likes cotton candy. Could be. I imagine, Fred, that there are astronomers on one of the rocky planets in the Kepler system looking at our solar system going, they've got planets that look like boiled lollies. Yes. How is that possible? Because that's Jupiter and Saturn do have that appearance. Or they might be going, what they've got rings around their planets. How is that possible?
Yeah.
Things like that.
That's right. Who knows?
We're used to what we've got, and when we see something that just doesn't fit our definition of a solar system, they write papers about it like this because it's hard to understand what's going on.
Exactly, but it's telling us stuff that we didn't know before, which is interesting. Yep,
it is. It is very interesting. If you'd like to read all about it, it's on the brighterside.news website. And I'm sure they've published a paper somewhere, yes, in the Astronomical Journal, of course. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Space Nuts.
Yeah, we do it hard here at Space Nuts, no doubt about it. Fred, let's go to Mars because in recent times, you and I have spoken about some of the things they're discovering about Mars and what it will mean for people who will ultimately spend lengthy periods on or in the planet, depending on whether or not they can find somewhere to put themselves. And there seem to be places popping up. This story, however, is all about groundwater and what it means for Mars's history as a wet planet. This is really, really interesting stuff.
It is, yes. I mean, I guess we're used to the idea that probably Mars's northern hemisphere had at least seas on it and probably an ocean. We've talked about several pieces of research recently that seem to suggest that it was actually a large body of water that lasted for a long time, covering Mars's northern hemisphere. But what we haven't sort of studied is the more detailed hydrology of Mars, the way the water behaves in Mars. But this is a paper that's come from Utrecht University, and it's about an analysis of craters in the northern hemisphere, so that region where there was an ocean at one time. These are craters which are quite deep. They are about 4 kilometers deep.
Whoa!
So they're big. That's significant. I think the crust of Mars is only something like 20 or 30 kilometers, if I remember rightly, unlike ours, which is 50 to 100 kilometers. But anyway, 4 kilometers below the sort of Martian datum, which on Earth we'd call mean sea level, but they don't have sea on Mars, so it's a sort of standard datum. Yeah. And what the analysis has shown is that there are features in the walls and bases of these craters which indicate presence of water over a long period, and that we've just talked about the ocean. I think we're talking here about a time when the ocean wasn't there, because these are craters in the northern hemisphere. But in these deep craters show water-formed erosion and water-formed features in the bottom. But the smoking gun here is that for these 24 craters, most of these water-formed features occur at the same depth, basically. So what this seems to be suggesting is a water table, a bit like we have here on Earth. We've got groundwater that produces a water table, and that's suggesting that maybe at that depth there was a water table that was across multiple sites. And so that suggests that this perhaps supports the existence of a widespread groundwater system rather than just individual pockets of water. The fact that they're all at the same depth.
Yeah,
there's a quote from
that's the telling sign, isn't it?
It is, yeah. Dr. Salesi is the lead author, and a quote is, "We traced this water in our study as its scale and role is a matter of debate, and we found the first geological evidence of a planet-wide groundwater system on Mars." And So, that's also the idea that this is the whole planet is, I think, quite a step forward, that we've got a hydrological network kind of comparable with the Earth. It would go back to a time when when Mars was more geologically active than it is now. And I think the model that they're suggesting, I think I've got this right, is that as the surface water diminished, as this ocean dried up, it basically migrated downwards and basically formed a long-term stable water table, as it said, 4 kilometers beneath the surface. We know that there is still water under the surface in regions. I mean, thinking of the Phoenix mission that scraped the surface of the northern Arctic in Mars with its backhoe, and they only had to move a few millimeters of soil before they were on solid ice, which is basically, subsurface ice. So, in some respect, perhaps that groundwater table still exists in the form of ice. Really interesting piece of work, though, with some very interesting topological features in the paper that they've written, and you can see the evidence for these water-formed features.
Of course, Fred, I'm sitting on groundwater as I speak, not literally, but it's below my feet, below my house, all through this region, the Great Artesian Basin.
Yes, that's right.
In fact, it's so big and so well used, we'll say, that there's a department that is in charge of looking after it in this country.
Yeah.
And it stretches from Queensland right down through New South Wales and into Victoria and South Australia. I think it's massive.
Isn't it something like a fifth of the area of Australia is occupied by the Great Artesian Basin? I've got a map somewhere that I found online one day, and I was staggered by just how big it is.
Yeah, I've seen pictures of the basin as well, and to give people an idea of how significant it is, where I live, we have a river running through, but we also suffer some significant droughts at times, but we draw on the groundwater to supplement our water supply. We can never run out of water here, unless the Great Artesian Basin actually runs out of water, and that's one of the fears, that it's been overused for so long. Going back 100 years or more, they used to drill down, tap the water, and just let it run on the surface because it came up under natural pressure at a temperature of 50 degrees, I think, something around that mark. But it's a natural resource that's been used very, very heavily in agriculture and domestic supply out here for over 100 years, probably near 200 years in some respects. And now they're trying to figure out whether or not we've overdone it. And they've been trying to cap a lot of these old bores that have just been running water for decades without stopping. Yeah.
Do you know how deep it is, Andrew, beneath the surface? I'm just thinking. So when I lived in Coonabarabran, I lived on a property and we had a bore there, and the water was, I think, 90 feet, if I remember rightly. That's where we hit the water.
Yeah.
On our property, whatever that is in meters.
Okay, so it's the world's largest and deepest artesian basin. It's got a depth of 3,000 meters in some parts.
Yeah.
That would be its deepest point, but generally you got to drill down to about 2,000 meters to tap the water.
Okay, yeah.
Although in some places it naturally pushes up through the surface, even just out of town. From here, there are little pockets of water that are naturally at the surface that are hot, spring water.
Okay. Yeah,
and even up, move further north, you've got those famous bore baths in places like Moree and Lightning Ridge and Pilliga. Yeah. So it does come to the surface naturally, but to actually tap it under pressure and get it to the surface, you've got to go down pretty deep by the look of it. It's fascinating, though, isn't it? And it shouldn't surprise us that Mars probably had groundwater in its past, but it sounds like it was post-ocean time.
It does, from what we are reading here.
So does that suggest that the water migrated underground as the planet changed?
Yes, I think that's the bottom line. I think that's what these authors are suggesting. That happened. It receded downwards.
We just keep learning so much more about Mars, and I can't stop being fascinated by the place. It's incredible. You can read about that at the dailygalaxy.com website, or you can go to the paper at the Journal of Geophysical Research, Planets. That's it, Fred. We are done and dusted. Very quick today.
Neat and tidy. Yep.
Yeah, it's. I got the same philosophy with golf. A quick game's a good game. Unfortunately, it never works out that way because I hit it too many times. But thank you, Fred, and we look forward to your company on the next episode.
I'll look forward to yours too, Andrew. Thank you. Cheers.
Professor Fred Watson, astronomer at large, talking astronomy and space science every week. Don't forget to visit our website while you're in between episodes. You can get your Astronomy Daily news feed. You can sign up for that. You can send us comments and questions on the Ask Me Anything button at the top. It's labelled AMA. You can have a look inside the shop, and don't forget to leave reviews. There's even a review button there if you'd like to leave reviews about Space Nuts. We'd really appreciate it. And thanks to Hugh in the studio. You're going to love his excuse today. He heard about Martian groundwater and thought that you could grind water, so he's been trying that, and it's not working, and he's not giving up. Anyway, that's today's excuse. And to me, Andrew Dunkley, thanks for your company. We'll see you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.